For our experiment, we'll be using the binomial distribution. Our exponent n will be 3, and this will correspond to 3 spinners. Okay, let's do the layout of that. Here's the argument. P plus Q cubed equals 1. Alright, it's easier to break that down into 2 parts, I think. P plus Q, P plus Q, P plus Q equals 1. I'll just do the first 2 terms, and you'd get P squared plus 2PQ plus Q squared times P plus Q equals 1. And we could break that down, or multiply it out I should say, and we get P cubed plus P squared Q plus 2P squared Q plus 2PQ squared, plus Q squared P plus Q cubed. And we can see that we have parts that add up here and here. Okay, so those will all equal 1. Now let's arrange it so it's a little crisper and explain what it all means. Okay, when we lay it out, it will be P cubed 3P squared Q 3Q squared P and Q cubed. Okay. And those will have to sum to 1. Alright, what do these mean? Well, we said P is the probability on. So this is the probability on. All on. Okay, this here, the second one, would be the probability of 2 on, 1 off. This would be the probability of 2 off, 1 on. And this would be the probability of all off. Let's put down all. Okay, what does that mean? Well, P cubed is when all 3 spinners are on. Okay, well, we have one way to do that. Next one would be 2 on, 1 off. Well, here's one way to do it. Here's another way to do it. What's the third way? Oh, there's a third way in there. Okay, there's 3 ways to do that. There's also 3 ways to pick 2 off, 1 on. 2 off, 1 on. Okay, so there's one way. So there's 3 ways. Yeah, see, it makes perfect sense. There's 3 of them. Okay, only one way for them all to be off. And that's this. There's no arrangements involved. Okay. Now, for our experiment, we chose our sector size very carefully. And what we're going to look for is the probability of them being off is equal to 1/2. So this is sort of like a coin in a way. You give it 3 spins, and you have a 50% chance of it landing on one or more of the on zones. You have a 50% chance of it landing in off zone. Hope I got that right. And we'll list these out. The sector size here I chose to be 0.2063. That's on, their on part, and I will list those out. Okay, so we got probability of all on. That was p cubed, so that's 0.2063 cubed. That's all on. And numerically that's very close to 0.0088. Okay, the next one, 2 on, 1 off. And we had 3 times 0.2063 squared, and then we have to put in the probability of it being off, which is the remainder of the circle. So it's 1 minus 0.2063, so it's 0.7937. And that sums up to 0.1019. Okay, let's make this a little crisper. Okay, we have 3 chances at getting the order of 0.7937 squared 0.2063. That's 1 on, 2 off. And that equals 0.3910. Okay, now here's the fun part. We have 1 chance of none being on. So that's 0.7937 cubed. That equals 1/2. And this is all off. So our chances of winding up in the all off zone is 1/2. Our chances of 1 on, 2 off is roughly 39.1%. The chances of 2 on, 1 off is roughly 10.2%. The chances of all on is very teeny, as you can see. What is that, 1/10 of a percent? Close to 1%. Okay. Now, when we spin our wheels, we'll need a tallying chart. We'll use the right-hand side of this one for now. There's 2 experiments here. We'll be tallying none on, 1 on, 2 on, or 3 on. None on, of course, means that they're all off, and it will wind up in the white zones for all 3 of them. Okay.